This tutorial is going to show you how to create a Google spreadsheet that will allow you to explore the behaviors of different types of functions. In the end, what we're going to create is a spreadsheet that has 4 separate tabs in it. The first one will model linear equations, the next exponential, the next quadratic, and the final radical. This tutorial only covers how to create linear and exponential models. Let me show you first what you're going to end up with when you're done building your spreadsheet. So first, what I have up here is the general form for the equation for a linear function, y equals mx plus b. I happen to have it in slope-intercept form. The letters m and b stand for things that we call parameters. These are numbers that change the shape and location of the graph of a function. We know that m is the slope that changes the steepness of the function, and b is the y-intercept that moves the graph up and down. Then what I have here is a table of values with a variety of different x inputs and the y inputs that go with them based on a particular equation. The 3 cells that are colored here are the only 3 cells that I'm going to enter any data in this spreadsheet. So the way that this one works is I can change the slope by putting a different number in the box that contains the parameter for m, the slope. So right now, this line has a slope of 2. Suppose I wanted to see what happens if I change that to a slope of 3. If I change this, the steepness of the line changes. Slope controls steepness, and everything else in this spreadsheet automatically updates based on that. If I want to change the y-intercept, for example, instead of a y-intercept of -2, what if I wanted a y-intercept of +10? As soon as I enter that, the graph changes. You can see the y-intercept now is up here at 10, and everything in the table of values changed automatically. So I've set up a spreadsheet where I can change these 2 parameters, these 2 things that alter the look of the graph. Notice that the one other thing I can change is the starting value in the table of values here. So for example, let's say that I had a line with a slope of 1/2 or 0.5. And I wanted a y-intercept on this one of 40. If I do that, you see what happens is that, the graph is actually somewhere up here. I might want, in that case, to change the starting value for x here. So I might want to have the table of values start at a different number so that I could see the graph somehow. And I would be able to play around with the different numbers here until I found a number that actually showed the graph on there. So, and I could change my slope a little bit, and I can change these numbers. Again, you can see I can change the starting value. Okay, now I can see the graph a little bit there, but it looks like I can only see part of the graph. But suppose I started the x at -20 in this case. Okay, now I can see some more of the graph. So by allowing the user to change these 3 values, we can change the parameters and explore how they make the function look different, and we can change the starting value. So now let's look at how we actually create this sheet and the graph that goes with it. I'm going to hop over to a blank sheet. The first thing you want to do in the top is you want to enter the general form for the equation that we're going to model. This is a linear equation, and the general form we're going to use is slope-intercept, y equals mx plus b. This is not doing any work in the spreadsheet. This is simply a bit of information. The next section that we need is the parameters. In this equation, the parameters are m, which stands for the slope, and b, which stands for the y-intercept. These are numbers that I'm going to plug in, so I'm going to make the boxes here. I'm just going to shade them a particular color. It doesn't matter what color you use, so that I know that these are places that I'm going to enter data. So let's say, for example, that I wanted to graph the line y equals 3x minus 4. In that case, what I would put in the m box is the slope. In this case, it's 3. And what I would put in the y-intercept box is -4. That's my y-intercept. Okay? Suppose instead that I wanted to graph the line y equals 0.5x plus 2. In that case, I would put the 0.5 in the slope and I would put the 2 in the y-intercept. Okay? So that's how the two boxes that hold the values for the parameters work. Next, I need to make a table of values, and it's going to have a column for the x values and a column for the y values. Now, the starting x value is a number that we're going to plug in. So I'm going to put a little yellow box there to indicate this is a place where we can enter. Let's say that we want our x values to start at -5, and I've just sort of picked that number at random. What we want to have happen then is we want our x values to go up by 1 every time. So what I'm going to do is I'm going to set, right now I'm in the cell below the starting one. I'm going to have the value in this cell be a formula, equals the cell above it plus 1. So I'm simply going to have each cell take the number that's above it and increase it by 1. I don't have to retype that formula a whole bunch of times. If I grab the corner here and pull it down, what you'll see is that the formula, when it copies down, every cell takes the number above it and adds 1. So I could take this and add it for as long as I want. And now when I change my starting value, let's say that instead of starting at -5, I started at +4. All of the rest of the x values change automatically. Now we need to put in an equation for the y value, and this is a little bit trickier, so this one you want to follow on fairly carefully. In our general form, the value of y is m times x plus b. Let's build that in this box here. So y equals, we start off with an equal sign to create a formula. M, the slope, so I click on the box that has slope in it, times x, the x value I've plugged in, plus b, the y-intercept, so I click on the box that has y-intercept in it. Okay, so in this particular function, right now we're working with the equation y equals 0.5x plus 2. If I plug in a 0 for x, I get out a 2 for y. Now it would be really nice if we could simply take this formula and copy it down. Let's see what happens if we do that. Let's say that I move this formula down. If I click here, let's see what happened when I moved the formula down by a box. Well, the value it's looking at for x went to the next box in the table. That's good. Each y should go with the x that's next to it. But look what happened to where it's looking for the slope and y-intercept. Those two values moved down a box as well, and that's not right. So we have to delete this formula. Let me show you how to lock in two values. The two values we want to stay locked in. We want this formula to always be looking at B5 in my sheet. It's column B, row 5, for the slope. We want this B5 to be locked in. The way we lock in a row or a column is we insert a $sign. I know that seems kind of odd, but we insert a $sign in front of the thing we want to lock in. So for the slope, I always want it to be looking at cell B5. I want to lock in the B and I want to lock in the 5. So I'm going to put a $sign in front of the B and a $sign in front of the 5. Now when I take this formula and drag it down, that B5 reference, what cell it's looking at, isn't going to change. It isn't going to move. A10, we do want that to move. A10 is looking at the x value. And each time I copy this formula down, I do want it to be looking at the x value that's one row further down. But the B6, this reference here, we want that to always be looking at the cell that has the y-intercept in it. So I want to lock that in as well. I want to put a $sign in front of the B and a $sign in front of the 6. So that's, we call it a static reference. That means this formula is always looking at that exact cell. It doesn't change. Now I can take this formula and copy it down. And let's take a look at what happened. In this cell, notice the x value it's looking at moved down to the next cell, but the slope and the y-intercept, it's still looking at the two values above. So I can take this and copy it all the way down. And now I have all of the x values that go with the particular y values I've chosen. Again, notice if I change a parameter like the slope, everything, all these y values are going to change accordingly. If I change the y-intercept, all of these y values are going to change accordingly. The last thing we need to do then is we want to make a graph of this data. So to make a graph of it, I need to highlight the data, including the labels, the x and y labels. And then I go up to the insert chart, which is here. And I'm going to insert. Now it gives me some options here. This y versus x with a line is a nice option. That creates a smooth line. And you can see as I hover over it, I can see the individual points on it. That's great. That's cool. There's also another type if you would like. You can do a scatter plot. If we scroll down, that shows you the individual points that you have graphed in your XY table. In either case, it'll give us a good sense of what the line looks like that has all these points on it. I'm just going to go with a scatter plot for this one. Okay, so here's our graph. Looks all good. The one last thing that we want to do is we want to lock in the axes that our graph is using, and I'll show you why. You know, for example, that if I take the equation and I make the slope significantly steeper, let's say that instead of having a slope of 1, I put in a slope of 5. What I want to see is that my line gets much steeper. But let's watch what happens if I change the slope from 1 to 5 without locking in these axes. The line doesn't really look all that much steeper. And the reason is the graph automatically adjusted our y-axis to be much bigger. And this kind of distorts the look of the graph. So what I would suggest you do, double click on the y-axis, and let's have the y-axis go from -20 up to +20. This is kind of like what we do on our graphing calculators when we change our window view. And let's do the same thing for the x-axis. Again, double click right on the numbers for the x-axis, and we're going to go from -20 up to +20 as well on that one. Now, this may sometimes cut off parts of our graph, which is fine. Again, we can choose to start, let's see, it looks like in this one I could start my x values. Perhaps I could start them at like -10. Okay, now I can see some more of the graph in there. So now you've completely built a graph that'll show you as you change the slope and the y-intercept of your line, you'll be able to see how the graph changes. The reason that this graph doesn't continue on forever in both directions like the real line does is because it's only graphing the points that are in this table of values. If I wanted to see more of the line, I would just need to put more x and y points in there. What I'm going to do now is hop over to the exponential functions. And I'm just going to show you what you'll need by way of a general form and parameters. And then I'm going to let you build the equation. So the general form for exponential growth or decay is as follows. Y equals A times the quantity, 1 plus R raised up to the x power. So in this case, x is the exponent. This little character, this little caret up, is how we show raising something to an exponent. That little character is Shift 6 on your keyboard. There are 3 parameters in this function. There's 2 parameters and 1 variable in it. So A is our starting value. And then R is our growth rate. If R is positive, it's a growth rate. So 0.25 is a 25% growth rate. If it's negative, like -0.25, then that's a decay rate. This is something getting smaller. It matters in this case that the number that we have, if it's negative, that it be greater than -1. So we can't plug in -2, for example, in there. We have to have something that's greater than -1. Put this in as -1 there. And what this really is the growth or decay rate expressed in its decimal form. So for example, a 5% growth rate, we would type in 0.05. What I have here right now is a 25% growth rate. That's 0.25. And then x in this case is going to be the time, how often we're looking at this. So let's see, it really probably only makes sense in this case to start at 0 there. And then the equation that's listed in here, that's in y, goes with the general form. So y is a times 1 plus the growth rate raised up to the x power. So you're going to create this equation the same way that you did the linear equation by locking in the references to the parameters and allowing the reference to x to move. And then you're going to create the graph the same way. For your graph, I would suggest -20 to +20 on the x-axis is still a good idea. These graphs grow and shrink very quickly, so you might want like -50 to +50 on your y-axis. Later on, we'll add in quadratic and radical functions.